Hi, welcome to Explain It to Me. Here we're going to be looking at this evaluation board from Atmel for the ATmega 328P. I've got one here on the webcam. I'll just drag that up. So on the board you will notice that there are two microcontrollers. This is the one of interest to us. It is the ATmega 328P. The larger one is an Mega 32U4 microcontroller. It's a 32-bit microcontroller. It handles the communication between the PC, which is plugged in on this micro USB, and the microcontroller of interest, the 328P. So just ignore this one. This is the one we're interested in. What else have we got on this board? We've got a little LED down here. Got a little program in here. Makes the LED flash. And of course next to that is a switch. Other important things are some areas for you to solder things into to make little circuits. But the microcontroller pins themselves come out on these solder points here. There are 8 here. There are 6 along here. And there are 6 over here which are connected to the microcontroller. So that's the board. How do we go about using it? Students often find it very difficult to get started with microcontrollers, and so I've developed some software, Microcontroller System Designer, which allows you to do some interesting things to get started and understand micros. So we'll start this with a new project. It's in my Explain It to Me, and we will go Explained and Flash1LED. So that's our start. Now we've got an empty project. Let's create our block diagram to go into it. It'll pop up with a name. You can change the name and the name of the person logged into the computer. So now we've got a blank block diagram. We're going to add a microcontroller to it. We've got different micros that we can drag and drop on here. One of interest to us is the Explained. So I'll drag that in here. There it is. Zoom to fit. And you'll see that we have a switch and we have an LED. So the actual LED is here, but it's connected to port B.5. This is B.5 up here, so that's why there's an LED on the drawing here. Just so that we can visualize it and see what's happening to it. The switch is on B.7, which is actually down here. So that's been added to this point of the diagram. These are the other connection points which are on your board. So if we go back to the webcam, you'll see that there are 6 here, and they are C0, C1, C2, C3, C4, and C5. So that's port C. Over here, we've got 8, which are port D, from D0 through to D7. Up here we have quite a few places for soldering things into, but 6 of them are connected to the microcontroller directly. That's B0 through to B5. So that's these lower ones here. The others have got voltage and things on. So at the moment we've got only an LED and a switch, and we're going to learn how to program this LED to flash on and off. So this is the very, very first introduction. We're on B.5. These are called ports. Port B, port C, port D. Don't mistake this for a port A. It is not port A. Port A doesn't exist on a 328P. Only these pins do here that you have access to. Right. Now, what we can do is we can right click and imagine if you could look inside and see what's happening. So here we go. We're looking into the memory of the microcontroller, and these things come empty. Although when you do buy your Explained board, it's got a little program on it, Morse code program on it, but this is empty, and this is what we would normally be faced with when we wanted to write our own program. As I mentioned, students find this very difficult to start with, but once you're over the initial hurdle, it's cool fun. You can get into these and have a lot of fun about them. But what we can do then is I've developed some software to auto-generate a code template for you in here. Now that code template looks at what is connected to the microcontroller that you've connected on this diagram and brings in all the necessary things for those external devices, the inputs and outputs. So we'll generate that. As well as that, it builds a whole lot of other stuff that are very useful to you when you're learning to program. At the top of your program, you should always have some sort of description. And it'll have your name, and it'll have a date, and have the file names so that you know what this thing is called and where you saved it and when you did it. And it'd be a really good idea to put in here something about the program. So I'm going to call this First Embedded Systems Program Flash the LED. Okay, so that's just something about the program. The next thing it needs is our system, not the microcontroller, but our system that we're using. It needs to know the speed at which our microcontroller is running. Now, the circuit here has got B0 to B5, as you can see on this diagram, and B7, but no B6. B6 is a line that goes between these two microcontrollers, and this microcontroller feeds our 328P with a 16 megahertz clock cycle, and that is actually being used on that B.6 pin, so that's why you can't use it. Another thing that's really useful to have in your program is a whole lot of includes, and that means include this file, but only include the functions within that file that we use. So that won't include a lot of stuff, just the ones we need. We're going to be using something in the delay file soon. This is where we get into the interesting stuff. These are the things that have been configured automatically because the microcontroller is connected to some inputs and outputs. So this LED here, this yellow LED, is we can turn it on with this command, set the LED. We can turn it off with this command, or we can toggle it, change its state from on to off. The switch down here we can read, and so we need to be able to know, we need to know whether it is low or whether it is high, and we'll get into that in the next video. Some more areas for other things that become important in our programs as they grow larger. But here's the main program itself, and this is very typical. C int main void, and it runs this program. When it starts, whatever's in these two braces here will run. An important thing to run is to tell our hardware how it should be configured. Initially, microcontrollers such as the Atmel 8 series come as all these device connections are inputs, not outputs. So if we want to connect an LED to it, we've got to change something to an output. What I normally do is I set up all of the pins as outputs to start with, and then I configure the inputs that I want to use. So that, for instance, this is on B.7, and it's a bit of a old habit. These pins, if they're left unconnected and they are set up as inputs, then the potential then is to drift in voltage. If, however, we set them up as outputs, then they will automatically be set at 0. We don't have to do anything about that, so that's fine. If they're left as inputs, then the voltages that are floating around on the circuit board might interfere with them. Then, of course, we do need to set B.7 as an input because we've defaulted all of those to outputs. Now we get into the main part of the really interesting part of the program. When the microcontroller starts, it's going to enter at this point, carry out these commands, and then get to this while one. Now the while one, this is the really important part of an embedded system program. This here is what we might call the automaton. These microcontrollers are part of embedded systems, and embedded systems often run without any human intervention, and so they need to be completely automatic. So an automaton is something that is just mindlessly automatic, and that's exactly what we need. Something that will run without any human intervention if we want it to. And this is really one of the first defining characteristics of embedded systems, the fact that they are automatons. And so what this while means is while everything inside these two brackets is true, carry out everything inside these two braces. So we can type some code in here. So the program will start at main up here, carry out these few lines of commands, anything else you want to put in here. Then it will enter this loop and it will stay here until the power is turned off. That's the automatic bit. And so while whatever is inside these brackets is true, do whatever's inside these two braces. Well, what's inside the brackets at the moment is 1. 1 is always true. 1 is true. 0 is false. 1 is true. In fact, I think anything that's not 0 in there is true. So we'll go down and we'll write some code here. Now, again, it's a little bit tricky. Where do we go? How do we turn on an LED? Well, I've got these macros predefined for you. So let's use them. Just right click here and you get access to the macros. We'll set the LED, enter, and then we will clear the LED. Hey, that's cool. Now, just a little word of warning. I did mention that these microcontrollers are running at 16 megahertz. That's 16 million instructions per second. If you want to see the LED flash, then you're going to have to slow this thing down. That's a really important part of microcontroller programming, is to think about the relationship between the program and what is happening in the real world. And sometimes you have to slow the program down so that it can interact with the real world. Now that really is just the fact that, well, people are so slow compared to computers, even a little microcontroller that runs at only 16 megahertz. This instruction will happen in 1/16th of a millionth of a second. So the two of them will happen in 2/16ths of a millionth of a second. We will not see the LED flashing. We need to pause this thing. And there's this little function we have access to called delay. And so we're going to delay it for 1/4 of a second. Now I've turned it on, I've delayed it, I've turned it off, and then I'm going to go around in my while loop again and turn it back on again. So if I don't put in another delay here, it's not going to see it. Or we're not going to see the LED flashing. It won't turn off and then wait. So now we've got a bit of code. Let's run it and see what happens. There's our LED flashing on and off. And you can see that the effect of this line set LED 0 isn't so much to set the LED, but to actually turn on some voltage at this point here, port B.5, and then turn it off again. And of course anything connected to that port, like an LED, will get the voltage or not. Hey, that's cool. Control A, Control C. Let's go on to the next part of our process, which is actually poke this thing into our microcontroller. So I opened up Atmel Studio 6.2. You need at least 6.2 to work with these. And if your Xplained mini board is connected, then this page will pop up. What we're going to do now is we're going to create a new project. It's a GCC executable project, and we're going to put it into this folder. So make sure you've got a folder where you want to put yours. I put mine under my Xplained folders. And what I'm doing is I'm calling these Xplained, and this one is Flash1LED. So that's the name of my project. You don't need to tick this to create directory because it's going to be in its own directory by default. This creates another subdirectory. Then it's going to want to know which microcontroller we're using. So there's an awful lot of microcontrollers from Atmel, but we're using the 328. And there you go. There's only 2. Make sure you choose the P. So this is going to pop up. We've got a blank code template. It doesn't have much information in it. It's not too helpful for novice programmers. So I'll just Control A and delete all that, and then paste in the code from System Designer. And that's all ready to go. And we'll go to Build, and then Build Solution, or you could press F7. And what we're looking for down here is this succeeded comment. And that now has been compiled. What that means is that it's taken this high-level language code here and it's turned it into machine code, binary ones and zeros. More about that later on. Then we have to program this into the microcontroller. So we've got to Tools, Device Programming, and if you don't see it, it should come up here in this little drop down and then Apply. Cool. Looks like everything's okay. We can read the device signature, and that is this particular code here. That tells us that it is a Atmel AVR8 80 mega 328p. So that's specific to the 328p models. Then we're interested in poking it into the memory. Now the microcontroller has different memories, but the one that is importance to us for the program is called the flash. And it's a three-stage process for programming. First of all, it erases the device, makes sure that there's no program in there to start with, and then it programs it, and then it verifies it. And verification means read back from the microcontroller into Atmel Studio, compare what you read back with what you thought you sent, and see if they're the same. So let's do that. Let's click on Program and watch what happens down here. Very quickly, it erased it, it programmed it, read it back and confirmed and verified that it was all okay. So now we should just see that our microcontroller has a flashing LED. How about that? Well, that's a really brief and quick introduction to getting started with this. Hope it's been useful to you.